Okay, so hi everyone, I'm Federica Gamba from Charles University in Prague, and as Alexis introduced, I've been working with Alexis and Dan Zeeman, my supervisor in Prague, on this second approach to leverage existing resources in order to avoid that the annotators have to start from scratch, but in order to provide them with some kind of skeleton of a UMR, so that the whole annotation process is faster. This whole system leverages universal dependencies. I am sure that many of you know UD, but just in case not everybody is familiar with it, let me say a few words. So UD is a framework for consistent annotation of natural languages that focuses mostly on morphosyntax, which means that it provides a way to consistently represent, for example, part of speech tags, morphological features, and syntactic dependencies. UD is a community effort, open community effort, which means that basically everybody working on their language can build a tree bank, maintain a tree bank, and then contribute it for the official release. And that, I think, is really the strength of UD, because it led UD to cover, in the latest version released just last month, 179 languages for more than 300 tree banks. And I really think this should be the direction in which UMR goes as well, but of course it's not as easy. As I said, UD focuses on morphosyntax, meaning that it is not a semantic resource. For this reason, we cannot really expect to extract full UMR graphs, but even partial UMR graphs, as in the case of IGT, is already a variable outcome. In the slide, you see just an example of a UD tree. UD trees are related trees, so you have a root, which is the main predicate most of the time of the sentence, and then every other token is attached either to the root or to its head. I'm going to show you the UMR of this sentence, so keep in mind. Okay, a few words about the conversion from UD to UMR. Most importantly, this conversion is not language specific, which means that we cannot rely on external resources that provide predicate argument structure, which implies that we're rather targeting stage 0 notation. If you remember, Julia introduced stage 0 and stage 1. In simpler words, stage 0 means that we are using role labels, participant roles like actor, theme, and undergoer, rather than lexicalized participant roles like arg0, arg1, and so on. For this same reason, we cannot disambiguate concepts, so we just have to rely on UD lemmas. So, for example, we cannot have run O1, which would be a sense disambiguated concept. We just have run. And then, basically, the core of the conversion revolves around the mapping between mostly dependency relations and participant roles. However, we do not only exploit dependency relations, but also, for example, universal features such as case, polarity, tense. And this conversion, this mapping, does not always output participant roles. Sometimes we have to introduce a more complex structure, such as, I don't know, an abstract predicate. As I said, UD is not a semantic resource, so there are some issues that we have to face and that we cannot really solve. For example, introducing abstract predicate structures is not really always working, in the sense that the syntactic structure does not often or always correspond to the structure of the abstract predicate. Sometimes events are not expressed through a predicate, and this means that we cannot really identify them. Most of the time, an event is expressed as a predicate, as a verb, and that's okay for us to figure out because we have the part of speech tag. But when this doesn't happen, we basically have no clue. And then so on. Reentrances, for example, are also quite complicated because UD does not mark them. An aspect we discussed yesterday, sometimes it is encoded morphologically, but not really always. So this explains why we have, for example, this aspect table here. But let's take a step back. We have here the gold graph on the left and the generated graph obtained from UD on the right. As you can see in this case, and this is the sentence from 2 slides ago, in this case the conversion works pretty well. The structure is exactly the same. There are 2 differences which are highlighted in red. One, as I said, it's aspect, so we are not able to extract the value, the state value of the aspect attribute, but we can at least insert in the graph a placeholder, so that the annotator doesn't have to remember that they have to annotate aspect, they just have it there, and the only thing they need to do is just replacing the placeholder with the correct value. Then the other difference is this entity. We have Martin Luther King Jr. That has to be treated as a person entity. So we build this structure, if you remember from hands-on. The thing is that from UD we cannot really extract the type of the entity type. So in this case it's person, but it can be really anything else, thing, or even way more specific types. So what we do, we just again use a placeholder, which is type of named entity, and then the annotator is supposed to just replace it with whatever is correct. But overall, these 2 graphs nicely similar. Of course, with more complex sentences, that's not always the case. That would be very nice, but it is not the case. But as you can see, at least this conversion provides us with a good starting point. As I said, this conversion process is language independent, meaning that you take any treatment you want to work with, you run the converter on it, and you end up with your UMR graphs. More or less complete. However, some semantic information is encoded lexically, so we decided to make the converter somehow modular. So make it in such a way that it can use some lexical resources, very simple ones, that can be defined, and that, for example, specify interpersonal terms, such as mother, brother, housing, whatever you want, to assign this abstract predicate. Coordinating and subordinating conjunctions can be used to disambiguate discourse relations. And then, in the same way, we also assign some model strength values. These lexical resources are now available for these languages, Czech, English, French, Italian, and Latin. But really, they're really simple and can be easily prepared for any other language. So, of course, we had to evaluate this whole conversion process. We ran a quantitative evaluation that I'm not going to talk about. It's a lot of numbers. But more interesting, we also tried to measure how much time, how much faster the annotation process becomes if annotators are provided with these regenerated graphs. And as you can see from this table, the time reduction is interesting. These numbers, 44% faster, 48:30, and then there's this 8. This is Julia's fault.
Why such a difference?
Julia,
Why such a difference?
you done? Let me explain. So Julia, yeah, we observed that the role of expertise is really, really important. Because for all the other annotators, time reduction is really substantial. But when the annotator is already super experienced, like in the case of Julia, probably only Julia in this work, but the time reduction is not as much. But this means that this conversion process can be really helpful for whoever is starting on a new language and doesn't want to start from scratch. So that was our goal from the beginning.
And the other annotations were conducted by beginner annotators, or this with some experience at least?
Some both. So, for example, Italian was me, and I would say I am somewhere in the middle. Czech, for Czech we had 3 different annotators. One of them was a complete beginner, and the other 2 were like more or less experienced. And then we had this second English annotator that is
some experience.
some experience.
And what about the quality, about the curation quality?
About
Have you checked the quality of the annotations that were conducted by annotators versus converter? Have you also evaluated that on some test set?
Yeah, we have evaluated. Sorry.
No, it's just that.
It's okay. I can.
Also yesterday.
The quantitative evaluation I mentioned earlier that we ran was to measure how accurate the converter is against the test set that was built this way. I just didn't show it here because it's really a big table, but it's in the paper that was on the first slide. So.
Did you look for the inter-annotator agreement?
No, we didn't. So for we could have for English only because for Italian there was just one annotator. For Czech, 3 annotators, but they annotate different subsets. With English we would have, but we just didn't. Can be fewer. Yeah. Yeah, that's pretty much it. So the converter is still.
I see this.
Yeah. So we are still testing the converter. So it's not perfect, but any feedback you would like to give me, it's really appreciated. In case anybody is interested for the hands-on session of this afternoon, I have prepared pre-generated graphs for these languages that, as I understood, are some of the languages that people here work with or speak. If something is missing, and it's missing for sure, just tell me. I will try to make graphs. That's it.
If I may just add a small note, the Kyrgyz one is my mother tongue, but this is not my tree bank.
Okay.
And this is from, I don't know him, this is another person, annotator.
So are you working, because I saw that there are 2 triggers.
Yes, the first one, this one is bigger one, but this is not mine. And I also don't know the person. As far from only from the name, I can say this, I would say this is a Turkish person. But I have no clue. And mine, and from my supervisor, Dr. Chortekin, is the second one. This is with 2 years CL. 2 years, 2 million. This is my university, not mine, but. And CL is computational linguistics, and there is Kyrgyz.
Oh yeah, I was wondering which one I should select. In the end, I picked this one because the star rating is higher. You know that UD has this rating system with stars. But I can generate graphs even.
No, never mind. This is just a small note. And there is one more thing for the parallel part, if I may. This one, if I'm not mistaken, please correct me. You have done and tried to compare the parallel sentences from part 1, SPUD, Trebek. Am I right? This Czech, English 2, and the Italian one, they are parallel.
Yeah,
the 3 banks,
it's the same 100 sentences in the 3 languages.
Okay, nice. Because I was just wondering, okay.
And they're available also in
UD,
Portuguese, French, Turkish, and Russian from this subset of languages because it's the same tree bank.
Okay. Cool. There is also one more parallel tree bank. There are 4 languages. They are pretty new from the name. There is Kyrgyz, there is Uzbek, there is Turkish, and there is Azeri. This is from Turkish languages. Cool. If it's interesting. And there are also only 150 sentences. I think catch your work. Just have some, interesting languages.
Thank you.
Federica, is the converter open source?
Yeah, I just have to make the repository public.
Nice.
But I can read it in a second. But yes, it is openly available.
I will be interested of using it. We already have Turkish UT bank, so it will be really
Sometimes
easy.
it may crash, but
That's okay. And do you have fixed sentences for them, right? You choose some fixed 100 sentences. So can you also share the sentences? Which sentences did you choose?
Yeah,
so that maybe we will start with them in the first place, so that maybe you are doing some repository and you can put Turkish as well. I don't want to choose different sentences.
Everything is in the same repo for now, like the converter, the test set, the scripts, everything is there. I will make it public in 1 minute and
Thank
for everybody.
Thank you for your hard work.
And compared to all the aspects of UMR, all the elements, Or, for example, does it contain also, does it contain, for example, discourse relations?
Oh, sorry, I forgot to mention this. We are working only with sentence level graphs.
Yeah.
Because from UD we cannot read. And the alignment block, we are also producing alignments, but we do not work with, we do not convert the document level block. So, as for discourse relations, only those that are expressed at sentence level are converted.
You didn't do it in document level because the sentences were just wasn't document level, right? There was no co-reference resolution between them or something like that.
It is not annotated,
Yeah.
so we cannot extract that information.
That's the problem.
This is really what I want to. Thank you so much.